Limiting and excess reagents is probably the most difficult part of the stoichiometry unit. It's going to be based on the information and the techniques that you've learned in quiz number 2 and quiz number 3. And the section that we're going through in the textbook is section 8.3. If you would like to see this material in a different way, if you'd like to see a different problem done in a different way, there's a good example on Khan Academy, and it's called a limiting reactant problem. It might be worth watching. So the basic concept of limiting and excess reagents is that in any chemical reaction, it's really easy to run out of something. And when you run out of something, it has an impact on how many products you can get. As soon as you run out of something, that means that your reaction will stop working. Any of the problems that we're using here, to solve the problems, you have to identify which thing is going to run out first. Whichever thing runs out first is called the limiting reagent. Once that thing runs out, you will have something left over. The thing that's left over is called your excess reagent. Sometimes you'll see these things called limiting reactants and limiting and excess reactants, same thing. So the example here that I'm giving you at the bottom is we have Lego. So what I want you to do is pair up the Lego. So you were given 3 yellow Lego blocks and 4 red Lego blocks. So if you pair them up, what happens is as soon as you run out of yellow Lego blocks, you can't pair them up anymore. So that means that because we're running out of the yellow Lego blocks, we can say that yellow is our limiting reactant or reagent, and I put an LR beside it. We can also say that we have something in excess, and we have one red, that red right there, in excess, so we can say that that is our excess reactant or reagent. We would be able to make 3 sets of pairs, and again, we have 1 red left over. Why do we care? We care about this. It's important to know how much excess you are going to need to make sure that your reaction goes to completion. So if I know that I want to react 17 grams of methane, let's say, in a reaction, I need to know exactly how much oxygen I'm going to need, or something like that. So the general rule is to assume that if we want to make sure we're reacting all of the limiting reagent, what we're going to do is we're going to use 10% excess. In commercial chemistry, they don't necessarily always use this much. However, we're going to assume that we're always going to need to use 10% excess. When we need to know how much we have, so the quantity of more than one reagent, what we'll need to do is we'll need to figure out which one is going to be the one that limits the reaction. We need to figure out which one is our limiting reactant. So here's an example of what we just talked about. You want to test the stoichiometric method using the reaction of 2 grams of copper 2 sulfate in solution with an excess. It's telling you that this one is an excess of sodium hydroxide solution. So I can put right away, I can put ER on top of my sodium hydroxide. What it's asking here is what would be a reasonable mass of sodium hydroxide to use. What that means is I want to use enough sodium hydroxide to react completely my 2 grams of copper 2 sulfate. What I need to do here is I'm going to do my normal stoichiometry, and then at the end I'm going to take my answer and add 10% to it in order to make sure that I have enough plus a little bit more, which is a reasonable amount. So what I'm going to do first is I'm going to do the stoichiometry that we've been doing now since the start of the unit. I'm going to first find the moles of what I know. What I'm doing is I'm taking my molar mass and I am taking my grams and I'm dividing it by my molar mass. I'm showing it here unit analysis, but you can do it in proportions as well. Now I have the moles of what I know. Next I'm going to use my molar ratio and I'm going to find the moles of what I don't know. So I'm always putting the moles of where I'm at, my CuSO4 on the bottom, so that my CuSO4 can cancel out. My moles will cancel out. Now I have the moles of where I'm going, or what I'm looking for, on the top. My last step is I'm going to find my question mark, which in this case is mass of NaOH, using my molar mass of NaOH. So again, either using proportions or unit analysis, I'm going to be multiplying by my molar mass. My moles cancel out my moles. Now what I have left is I have my grams of my NaOH, which is what I was looking for. My answer here, I'm getting 1.2 0.002 grams of sodium hydroxide. But I'm not going to round it yet because what my question's asking for is a reasonable mass. And anytime I'm asking for a reasonable mass, what I'm going to do is I'm going to take my answer and I'm going to have to add 10% to it. So what I need to do here is I need to do 1.002. Again, I'm not clearing my calculator. And I'm going to multiply this by 1.1. Multiplying it by 1.1, make sure I get back my entire answer plus my 10%. The other way I could do this is I could do 1.002 and I could multiply it by 0.1. That would get back just my 10%. The first way I'm doing it here, I'm going to get back an answer of 1.1026 grams, and if I look at my significant digits up here, I need to keep 3, so I'm going to have 1.10 grams as my final answer. In the second way of doing it, what I'm going to get is 0.1002 grams, and I have to take that and add it to my final, or to my initial answer, 1.002 plus 0.1002, and it will get me the same answer of 1.10 grams. For practice on this, do 321 number 2. The next type of question you can be asked is asking which one is the limiting reagent if you're given moles of each reactant. So here you've been given 10 moles of CH4 and you've been given 10 moles of O2. You have to figure out which one runs out first. What we need to do here is we need to say, okay, if I'm going to use all 10 moles of my methane, how many moles of oxygen would that need? And then if I'm going to use all 10 moles of my oxygen, how much methane would that need? And figure out which one will run out first. So my first step is I'm going to start with my 10.0 moles of CH4. And what I want to do is I want to figure out how many moles of oxygen I would need to react all of that. So I'm going to use my mole ratio, and I'm going to put on the bottom 1 mole of CH4 is going to need 2 moles of O2, which means I am going to get 20 moles of O2, and my moles of CH4, my moles of CH4 would cross out. What I can do here is I can kind of label my columns. The column over here is have, and the column over here is need. Now I have to do it with the other side as well. I have to start with oxygen and see how much methane I would need. So now I'm going to start. I have 10 moles of oxygen, and I'm going to use my molar ratio. I know that I am going to need 2 moles of oxygen for every 1 mole of methane, and my moles of oxygen will cancel out. I have 10 divided by 2 is going to need 5 moles of methane. Now what I have to look at, on the left-hand side, you can see that I have 10 moles of CH4. And in order to react all the oxygen, I am going to need 5 moles of CH4. So if I have 10 and I'm going to need 5, that means I have everything I'm looking for. I'm going to put a check mark there saying I have enough of that. The alternative, I can say, okay, well, I know I'm going to need 20 moles of oxygen, and I have 10 moles of oxygen, which means I do not have enough. Whichever one you don't have enough of is going to be your limiting reactant or reagent. So over here on top of my chemical equation, I will write down that's my limiting reactant, and this one is my excess reactant. Second part of this question is how much methane would be left over. So if I know that I have 10 moles of methane to start with, and once I used up all the oxygen, because all the oxygen is the limiting, it's disappearing, I know that I needed to use 5 moles of methane. I can say 10 moles minus 5 moles of methane. I am going to have 5 moles left over of methane. To practice this, there are some questions. This is a very similar question to what we just did. The big difference is instead of giving you moles, I'm now giving you grams. That means the first step we have to do is find moles and then do the same thing we did in the last question. So same question, which one will be the limiting reagent? So what we have to do first is convert things to moles, then use our mole ratio and determine which one will run out first. I'm going to start with copper. So here I have my 10 grams of copper divided by 63.55, and I can figure out how many moles of copper I have. In this case, I'm going to write it down so I can do my have and my need columns. Now I'm going to do my silver nitrate. So here I have my 20 grams divided by my molar mass, and I'm going to write down my answer is going to be 0.1177 moles. Then I'm going to write down at the top, this is my have column. This is what I have of each of them. It's important you notice that this is what I have of copper. Actually, I'm going to write that down. I have moles of copper. And here I have moles of AgNO3. Now we're going to do the exact same thing we did in the last question and figure out which one runs out first. So I know that up here, my moles of copper, I am going to have 1 mole of copper for every 2 moles of AgNO3. And on the bottom, I know that I'm going to have 2 moles of AgNO3 for every 1 mole of copper. I can cross out here my moles of AgNO3 and my moles of AgNO3 and my moles of copper and my moles of copper. I'm going to have on my bottom here, and I never rounded my numbers, I have 0.0589 moles of copper. And on the top, again, I'm never rounding, on the top I am going to have 0.3147 moles of AgNO3. I'm going to call this column on the right my need column. So now what I need to look at is on the left hand side over here, I have 0.157 moles of copper. In order to react all of that copper, I am going to need 0.3147 moles of AgNO3. In order to react this many moles of AgNO3, I am going to need 0.589 moles of copper. So I need 0.589 moles of copper, and up here I have that many moles of copper. So that means my copper, it looks like I have enough. My silver nitrate, I'm going to need 0.3 moles of silver nitrate, and I only have 0.1 moles of silver nitrate, which means I do not have enough. So over here on my copper, I have enough, I have extra. So that's my excess, and my silver nitrate is going to be my limiting. What that means is my silver nitrate will be running out first. This is a continuation of the last question. The first thing it's asking here is what mass of copper will be in excess. We knew that we were starting with 0.157 moles of copper in the last question. In order to react all of the silver nitrate, we had to use 0.0589 moles, which means in excess we are going to have 0.0981 moles of copper left over. What it's asking us for is a mass of copper left over. So I have to take my 0.0981 and I'm going to use my molar mass of copper to figure out the mass left over. So I'm taking my moles and my moles, crossing them off, and I am going to get a final answer here of 6.23 grams of copper left over. The last part of this question is asking what mass of silver is going to be produced. In order to figure out what mass of silver is going to be produced, you need to think about when this reaction is going to stop. This reaction is going to stop when this many moles of silver nitrate are gone. That means that the silver is going to be made until that is gone. So in order to do stoichiometry, to figure out the mass of the silver, which is what we're looking for here, we need to use the moles of the limiting reactant. So if you ever want to find out anything about the product, you always have to use the limiting reactant in order to do stoichiometry. So now I'm doing normal stoichiometry, and I'm using the moles of my silver nitrate. So I'm going to start with 0.118 moles of AgNO3. I need to use my mole ratio to get into moles of silver, which means I know that I have 2 moles of AgNO3 for every 2 moles of Ag. And that is now going to get me my moles of AgNO3. My moles of AgNO3 cancel out. And I'm going to now have my moles of silver. And the last step I have to use is my molar mass of silver. So I'm multiplying it by 107.87. And my moles are going to cancel out. And I'm going to get an answer of 12.7 grams of silver. In order to practice this, that's where you're headed. This question is putting it all together, which means it's asking you all the different parts that I could ask you. Notice in all of these we're doing a balanced chemical equation. So this is saying that I have a grams of my first reactant being combined with the grams of my second reactant. Then it's asking us a few different things. It's asking us, number one, which reactant is in excess? Number two, by how much is it in excess? And then number three, which mass of precipitate, which means the solid that's being produced in the reaction, will be obtained. So we're going to do them in order. We're going to do number one, which reactant is in excess first. Remember from our last examples, first step is find the moles of each, then use your molar ratio, and do your have and your need columns. First step, I'm going to look at my iron chloride. So I'm taking my grams of iron 3 chloride and dividing it by my molar mass of iron 3 chloride. And I am going to get that what I'm starting with is 0.1652 moles, and that's what I'm starting with of iron 3 chloride. So FeCl3. I'm going to do the exact same thing with my next one. Taking my 21.5 and dividing it by 40 grams. And I'm going to get that I have 0.5375 moles of NaOH. I labeled this column with this is what I have and what I'm starting with. Now I need to use my mole ratio to figure out what I'm going to need of the other compound in order to figure out what is in excess. So on the top here, I am going to use my mole ratio. I'm going to say that I know that I have 1 mole of FeCl3 for every 3 moles of NaOH. And that means that I'm going to take my 0.1652 and multiply it by 3, and I am going to get 0.4956 moles of NaOH. On the bottom here, I'm going to do the same thing. So I'm going to multiply it by 1 mole of FeCl3 and divide it by 3 moles of NaOH. And here, I'm going to get the answer of 0.1792 moles of FeCl3. You want to remember that in here what's happened is my grams have canceled out all the way along. My moles are canceling out in order to leave the units that I'm looking for. This column I'm going to label need. So here what we can see is that we have 0.1652 moles of iron chloride, and we are going to need 0.1792. So we are going to need more than we have, which means we do not have enough. When we look at our sodium hydroxide, we need 0.4456, and we have 0.5375, which means we have extra. So I'm going to go over here and label my FeCl3 as my limiting, and my NaOH as my excess. We just did the answer to number 1, which is which reactant is in excess. Now I can figure out by how much. So my excess reactant is my NaOH, and I know that I had 0.5375 moles of NaOH. I know that I am going to need 0.4456 moles of NaOH, which means left over I'm going to have 0.0919 moles. I can then take my 0.0919 moles and use my molar mass, and my molar mass here again I'm using sodium hydroxide, which means I have 40 grams in 1 mole in order to find how much I have left over. And I am going to have 3.68 grams of NaOH OH left over, and I just figured out my number 2. My number 3 is asking how much precipitate will be obtained. Remember that the precipitate is going to be only made until the limiting reactant disappears. That means that what we need to pay attention to for our stoichiometry is our limiting reactant, which is our iron chloride. So now I'm going to do normal stoichiometry, starting with my iron chloride and going to my precipitate. So I'm going to do my stoichiometry down here on the bottom. I've already found my moles because I know what I have is 0.1652 moles of FeCl3. I need to use my mole ratio in order to switch it into my precipitate. My precipitate over here is my iron hydroxide, iron 3 hydroxide. So I'm going to say that I know that I have 1 mole of FeCl3 for every 1 mole of FeOH3. And then I'm going to cross out my FeCl3 and my FeCl3. Now I'm in moles of FeOH3, and I need to find my mass of FeOH3, which means I need to use my molar mass, and my molar mass here is 106.88 grams in every 1 mole. And then my moles are going to cancel out, and I'm going to do my 0.1652 multiplied by 106.88, and that is going to get me an answer of 17.7 grams of my precipitate, which is FeOH3. And that is kind of the ultimate limiting reactant and excess reactant question. What I'd like you to notice is that I went really slow. I took very careful steps, and I made sure that I was labeling and making sure I was going through my work really carefully. Summary here. What you're going to do is you're going to figure out what the limiting reagent by choosing either reagent amount and using the mole ratio to compare the required amount, that's what you need, with the amount actually present, that's what you have. So you're making your have and you need list. Second point, the quantity that is in excess is the difference between the amount of excess reagent that is present, so what you have, and the amount required for the reaction, what you need. And if a question ever asks you for a reasonable amount, you're always going to figure out your stoichiometric equation and then take your answer and add an extra 10%.